All right, so let's continue from the same example with heights and arm span. So remember that beta 1 hat and beta 0 hat are still here, and the value s is still here. All right, so now suppose you have a person whose height is 175 centimeters. Then you can predict, so this is our x value, and you can predict this person's arm span. What you do is you plug in x equal to 175 into a least square line. So the predicted value y hat is equal to beta 0 hat plus beta 1 hat times x, which is 175. And plug into the calculator, this is what you get. So it's 179.868 centimeters. So it's not hard to predict arm span based on the height. But now we want to talk about uncertainties in these kind of predictions. So we want to talk about uncertainties in y hat. So essentially, there's two different kind of uncertainties. So when we say height is 175, we can measure the uncertainty in the average arm span. Among everyone with height 175 centimeters. So if you say x is 175, you can take every single person whose height is 175 centimeters and you measure their arm span and you measure the average of their arm span. That's one way. Or we can take one person and measure this person's arm span So these are two different ways to predict the value. And because the one on the right only takes one person with height 175 centimeters, so the uncertainty of the one on the right is greater than the uncertainty of the one on the left. Okay, so the quantity of the uncertainty this is called sy hat. It's given by the formula s times square root of 1 over n plus x minus x bar square over the sum of xi minus x bar square. And the uncertainty on the right is called prediction, stands for prediction. This is almost the same, so it's 1 over n plus x minus xi, x bar, x bar square over the sum of xi minus x bar square. But here we have an extra plus 1 here. It actually changes the value a lot. Okay, so in our case, every value needed is already calculated for you. Xi minus x bar square can be, the sum of them can be found here. X is 175 and n is 24. And s is here. So we have the value for everything. So in our example, sy hat, they're both calculated in the spreadsheet. Sy hat is this 1.700787, and prediction is prediction is 4.198. So S prediction is much bigger than sy hat. So we can use these two uncertainties to create an interval, and the interval created using the one on the left is called the confidence interval, which we are familiar with. The one with the interval created with the one on the right is called the prediction interval. Okay, and because the uncertainty on the right is bigger, so the prediction interval is wider than the confidence interval. So if you compare the two, this is wider and this is narrower. Okay, so now suppose in our example we want to create a 95% confidence interval and 95% prediction interval. Then first we find a center. The center is the predicted value, so the center is this value. So it's 179 plus 868 is our center. Plus minus, plus minus. Degree of freedom is still n minus 2. So degree of freedom is n minus 2, which is 22. So if you look at the table, we used this value in the previous video. So 22, 0.025 gives you 2.074. And multiply by the standard deviation. So this is 1.0787. And the one on the right is multiply by 4.198. Okay, so this is how you create confidence intervals versus how you create prediction intervals. And here's a small note regarding these intervals. So you notice the term x appears in the uncertainty. More precisely, the term x minus x bar, the whole quantity square, appear in the uncertainty. Well, this means if the closer x is to x bar, the smaller the uncertainty is. In both cases. So that means the confidence intervals and the prediction intervals have different widths depending on what the value of x is. So if we plot them with respect to all the values of x's, this is what you get. So then let's look at these figures here. So the one on the left is called confidence band. The one on the right is called prediction band. So how you do it is for each x, you draw the confidence interval. So this is confidence interval. And for another x, so for all the different x's, you draw the confidence intervals, and together it gives you a band between the two curves. It's called confidence band. And the same thing, for each x, you draw a prediction interval. And if you draw this for all the values of x's, then you get a band, which is called prediction band. Okay, so as you see, this is true for both bands. It's less obvious in the prediction band, but our previous note still holds. So the band is narrower if x is closer to x bar. So that means if you look at the center, which is about here, the bands are narrower compared to other parts. So that's one note. And another thing is, so because prediction band is the one that measures individual data, data point. So the prediction interval is the uncertainty in just one single data point with the x value. So we can say that the prediction band contains 95% of the population data point. All right, so that's it for section 7.3.